Hi. In this lesson, we're going to be graphing functions. And before we do that, we first have to work on 6 different graphs that we have to become better at understanding, looking at, visualizing, and seeing and knowing. So you ready? Let's begin. Now, the first 2 that we're going to work on are 3 that you've technically already worked on at some point in the past. The first one is called a constant. Now, notice a constant. Think about it. A constant means that it remains the same. If you remember from a previous lesson, we said constant always represents a number. So for example, when you have f of x equals c, what do we always write f of x as? We write it as y, and constant is just a number. So a constant is any graph that has y equals a number. Now that graph is always going to be a horizontal line, meaning it's going to stay as flat as can be. So in this equation, you're going to look at the graph and you're going to see the graph is as flat as you can, crossing through the number 2. That's your first graph of constant. Now the next one is not an actual function, but it is a graph that you want to remember. It's x equals a number. That's a vertical line, and it's also called your undefined graph. So an undefined graph is always going to be x equals a number. Remember, a constant just represents a number. Any number in the world, it could be a constant, and it's going to be a vertical line, so straight up and down. So think about a previous lesson when we did the vertical line test. When we draw a line up and down, that's what an undefined line will look like. Your third one that you're probably familiar with is called linear. That's your y equals x. Some of you may remember it as y equals mx plus b. That graph, linear, not sure you know why it's called linear, but the reason is this exponent that x has, it's really x to the first power. That first power makes it a linear function or linear graph. And it's either going to be a positive line like the graph that's shown below, or to the right, I'm sorry, or it could be a negative line that looks something like this. Okay? So those are 2 types of linear equations that you can work with. So again, 2 are functions, and 1 is not a function because it would fail the vertical line test, but the graph looks like technically a vertical line. That's undefined. The next 3 are 3 that you're not really as familiar with. The first one's called absolute value. Good thing about absolute values is that's something that we've worked on in the past. We actually did it in chapter 1, and we also did it in unit 2. An absolute value is when you solve and you get 2 types of answers, a positive and a negative, right? Notice something. This is a positive line, and this is a negative line. That's what an absolute value looks like. It's 2 lines, one being positive, one being negative at the same starting point. And your parent function is going to always start off at 0, 0. Next one, quadratic. Quadratic has 2 names, quadratic, or sometimes it's even known as a parabola. A quadratic function has an exponent of 2. Notice that a linear had an exponent of what? 1. A quadratic has an exponent of 2. And it looks more of a U shape, and it can either face up or face down like any other graph. Same thing with the absolute value. And the third one, which you probably practiced when we were finding domain and range, is square root. A square root, to me, is kind of like a shooting arrow. It always shoots to the right or to the left. It can go down, it can go right, but it's always going to have a starting point, and it just takes off like a shooting star. Okay? And that's anytime you do a square root. Now, you have to be careful with a square root graph because, remember, not every number can be square rooted. And also, not every number can be plugged in there in order for you to technically get an answer. So, for example, square roots graphs are usually going to always be positive depending on if there's no other negatives. So these 3 functions are 3 functions that should be brand new to us, but we should familiarize ourselves with this. And there's going to be a couple more we learn throughout the year. Okay, so for the first one, we're just going to graph it. That's all we're going to do. So the first example says graph the following. It says x equals 3. Now you got to remember x equals 3. If you memorize from the previous slides, x equals 3 is called an undefined graph. Why is it? Because x is always going to equal what number? 3. So what you want to do is you want to literally grab a point, and I'm going to put a point at x equals 3, which is right here. But x is always 3. So no matter if I go up or I go down, I'm still going to be at x equals 3. And then what does this graph look like? It's going to be an up and down graph at x equals 3. And hopefully you can see that. So again, x equals 3, x equals a number is always a vertical line at that number on the x-axis. Now don't forget, this is the x-axis and this is the y-axis. For part B, it says it says f of x equals -2. Wait a minute, what do we say f of x always is? It always represents what letter? Y. So really what they wanted you to know was y equals -2. Well, think about what we did for part A. Part A, we put 3 on the x. So what do you think we do for part B? Y equals -2. We're putting -2 on the what? On the y. So I'm going to put a dot at -2. And then that means that my graph is always going to be -2 on the y. So it doesn't matter if I'm going left or I'm going right. It's always going to be -2 on the y, which is why when I graph this, I actually do a better line. I'm going to have a horizontal line, which is called a constant, no slope. Okay. So again, when you're graphing either an undefined or a constant graph, you got to remember it's either going to be a vertical line at that number or a horizontal line at that number. Now we move on to example 2. Now this is where it gets a little bit interesting because right now we don't really know how to graph these. We're not really familiarized with the shape of it. So we should use a table. A table is always going to help us out, be more organized in getting this answer. So the first thing I'm going to notice, it says this: graph the following by using the given domain. The function is f of x equals 2x plus 1, and domain, which is short for d, is -1, 0, 1, 2. Well, remember, if they give you domain, how do you find range again? You take all of those numbers on your domain and you substitute it into your function to get the y's. That's what we did last lesson. So let's do the same thing. Now, what we're going to do is we're going to do in the middle. So for the first one, what you're going to do is you're going to do f of -1. Let me actually be a little more careful with this one. F of -1, and I'm going to plug it in. It's going to be 2 times -1 plus 1. 2 times -1 is what? -2. -2 plus 1 is how much? -1. So my coordinate, my answer is -1, comma -1, which means if I were to graph this, remember x comma y, I'm going to go to -1 to the left, and I'm going to go -1 down, which means this is going to be my first point. Now I'm going to do the same with the other one. So I'm going to plug in 0, which is substituting. F of 0 is equal to 2 times 0 plus 1. 2 times 0 is 0. 0 plus 1 is how much? 1. That's my answer, which is my y. So I'm going to go ahead and know that my coordinate is going to be 0, comma 1. 0 is in the middle, 1 is up. That's my second point. Now I'm going to do the same for the next 3. But question, we have to also get used to being able to know what kind of graph we're looking at. 2x plus 1, I hope you all agree, is a linear function. So our graph should look like a line. Whether it be positive or negative, we're going to find out. So then I'm going to plug the next one in, which is f of 1. And it's going to be 2 times 1 plus 1, which is going to be 2 times 1, which is 2, plus 1, and that's 3. So at 1, I know it's going to be 1, comma 3. That's my next point. And then I'm going to keep going. My last one is going to be f of 2. 2 times 2 plus 1. 2 times 2 is 4. Plus 1 is 5. So I know my coordinate is going to be 2, comma 5. And that's my answer. So now I'm just going to go ahead and connect the dots. And it's going to be a straight line in a positive direction. That's how you graph it. So every time that you get a question that says, hey, graph this function or graph this equation, all we need are values. We need x values, which are your domain. So you can plug them into your equation, make a table, it's easier. And then you just graph the points and connect the line, making that shape. Okay, so now we're going to go to example 3. Even though we didn't do it, if you want to start it just to see, go for it. Pause the video, try it on your own, and then play it. But what I'm going to do is I'm going to go ahead and graph this. So the first one says x squared minus 3. Do you remember what this looks like? Here's a hint. What's the exponent? It's a 2. A 2 is a what? A quadratic. So it should look like a U. So what are we going to do? We're going to take our points. We're going to plug them in. So the first one's going to be f of -1, which is going to be -1 squared minus 3. Now don't forget, -1 squared is -1 times -1, which is what? 1. 1 minus 3 is how much? -2. So my coordinate is going to be -1 minus 2. I'm going to graph that. And that's my first point. Now I'm going to do 0. F of 0 is going to be 0 squared minus 3. 0 squared is 0 times 0, which is 0. Minus 3 is equal to -3. So I know my coordinate is going to be 0, comma -3. I'm going to go to 0, comma, -3. That's my point down here. Now, I'm going to continue the pattern because my goal is to find a bunch of numbers that they have listed. In this case, they gave me -1, 0, 1, and 2, so I have to fill out the entire chart. It's going to be very repetitive and very tedious, but that's a good thing. It means you get the concept. So 1 squared, remember, every time you plug something in, you always use parentheses. 1 times 1 is 1. I'm going to do 1 minus 3. It's going to be -2, so I know my coordinate is going to be 1, comma, -2. I'm going to go to 1, -2, and that's my next point. Now, I actually have enough points to know that this is going to be a U facing up. If you notice, you see how you have those two dots, those 3 dots, you know it's going to face that, but we'll do the last one. F of 2 is going to equal 2 squared minus 3. 2 squared is 4. 4 minus 3 is 1. So I know my last coordinate is 2, comma, 1, and that's over here. So now I have an extra point. I have more than I need. I'm going to draw a U. I'm going to connect the dots. I'm going to draw my U. I notice I passed that. This one I'll kind of do the same thing. Do some 2 arrows at the end because you know this graph keeps on going. Now make sure your lines are a little bit straighter than mine, but this is how you graph your quadratic. You have a U facing down that happens to went down 3. That's the reason why from the original graph it went down 3. And that's it. So yes, it takes a lot of work, but it's not hard. It's just plugging in numbers and doing order of operations like we did in the past. So for example 4, what we're first going to do is we're going to look at the function. It says graph the function f of x equals absolute value of x minus 2 and minus 1. The first thing I really want you all to get really good at is when you see the equation, I want you to memorize, oh, this is an absolute value. Because that's going to teach you that an absolute value has to always be a V facing up or facing down, depending on the shape. But it's always a V shape. So knowing that is going to help you. Then our next thing is, well, what points do we pick because they didn't give us any? When they don't give you a domain, that's okay. You can find the values by picking your own domain. So I'm going to show you the best way to find the numbers. The best way is what I want you to do is I want you to take the inside of this and set it equal to 0. So x minus 2 equals 0. Add 2 to both sides. I'm going to get x equals 2. This should be the middle number that you pick so that you can benefit from the numbers you're about to choose. So I'm going to put 2 in the middle, and I'm going to pick one less than, one greater than. So for example, I'm going to put 1, 3, and 4. If you remember that trick of setting the inside, if there is an inside equal to 0, it's going to be so much easier. If not, just pick the normal values, -1, 0, 1, and go in that order. And if you need more points, just go ahead and plot them. So I'm going to go ahead and plug in 1. It's going to be f of 1 is equal absolute value of 1 minus 2 minus 1 on the outside. 1 minus 2 is the absolute value of -1. The absolute value of -1 is just going to be 1 minus 1, which is going to be 0. So I know my coordinate is going to be 1, comma, 0. So know that you know 1, comma, 0. You're going to go to 1, comma, 0. That's going to be right here, and then you're going to put a point. On the next one, we're going to graph 2. So it's going to be f of 2. And it's going to be 2 minus 2, and the inside of the absolute value with a minus 1 on the outside. That's going to equal 2 minus 2, which is 0. And then 0 minus 1 is going to be -1. So I know my coordinate is going to be now 2, comma, -1. And I'm going to go ahead and graph that. So when I go to 2, comma, -1, that's going to put me right here. On the next point, what I'm going to do is I'm just going to go ahead and graph it as well. I'm going to plug in 3. So it's going to be f of 3. And it's going to be the absolute value of 3 minus 2 minus 1, which is absolute value of 1 minus 1, which is going to be, I hope you agree, 1 minus 1, which you get 0. So I know my coordinate is going to be 3, comma, 0. Notice what happens on the next point. Do you guys see that V shape? It literally looks like that, which is great. So that means I don't need other points to be able to know my shape, because remember, an absolute value is always a positive and negative line meeting at the center. The reason why we set this equal to 0 was so that we can find the center point, which was at x equals 2. Now, this is a skill that you're going to have to practice and learn. So every time that you see a parentheses, an absolute value, something that has an inside with x, set that part equal to 0 and you now find your middle point. Last one, I'm going to plug in 4. I don't need it, but I'm going to do it just for fun. F of 4 is going to be the absolute value of 4 minus 2 with a minus 1 on the outside. Absolute value of, 4 minus 2 is going to be 2. Minus 1, absolute value of 2 is going to be 2. Minus 1, which I get 1. So I know my coordinates going to be 4, comma 1. Now, I didn't need this, but look what happens. When I graph 4, comma 1, it's right here, continuing the line, which means that I also know that if I wanted to, also going to be a point right here because it's going to follow the same trend because an absolute value has the same direction left and right hand side. Once you have enough points, just go ahead and connect your dots. Try to make it as straight as you possibly can because it's a V. And that's it. That's how you graph it. So if you get a question where you don't have values, it's okay. Pick your own values. And when you pick your own values, a shortcut, set the inside equal to 0, and that's going to be your middle point. Okay? The last example, example 5, take a look at the graph. First thing I always want you to do is look at the function and picture the graph in your head. Because if you memorize every single function that we're going to work with, it's going to give you a better idea of what the final result should be. So what I'm going to look at is focus on the square root of x. We said, if you remember, the square root of x looks like a what? It looks like a shooting arrow or a shooting star, depending on how you might want to memorize it. So when I graph my shape, it's going to look something similar to this. So I know, listen, am I doing it right? Yes, because it's following that form. So what are we going to do about numbers? Because they didn't give us the domain, so we have to list our own. Now remember we said the shortcut was to take the inside of this and set it equal to 0? Let's go ahead and do that. X equals 0. However, I'm not going to put 0 in my middle now. I'm actually going to start this off as my first point. Now, why do I do that? I do that because of 2 reasons. Think of a number left of 0, less than 0, -1. What happens if I go ahead and I plug in 0 into the inside? Square root of 0 is 0. But what if I found the square root of a negative number? Find the square root of a negative number? It's not possible. The square roots have to always end up giving you a positive value. So because of that, you have to be careful with this step. When you set the inside equal to 0, that's actually going to be your starting point, your first point. So now I'm going to go ahead and plug in 0, but what's the next number? I'm going to plug in 1 because the square root of 1 is 1. But what about 2? What's the square root of 2? Is that possible? It doesn't give you a whole number. So because of that, you can't use that. Think of the next number that you can take a square root of. 4. So the next number is going to be 4, the last number. Now, once you have your numbers, you can go ahead and plug it in. So let's go ahead and plug it in. I'm going to plug in 0. So it's going to be f of 0 is equal to square root of 0 plus 1, which is going to be square root of 0, which is how much? 0 plus 1. And 0 plus 1 is going to be 1. So I know my coordinate is going to be 0, comma 1. And I'm going to go ahead and graph that. Now, when I graph it, 0, comma 1 is going to be up here. I'm going to put my first point, which is my starting point. Remember the shape. It should look like a shooting arrow. Okay, so I'm going to plug in my next point, which is going to be 1. So I'm going to plug in f of 1. And I'm going to get the square root of 1 plus 1. And the square root of 1 is 1. 1 plus 1 is equal to 2. So I know my coordinate has to be 1, comma 2. That means that my next point is going to be at 1, comma 2. And if you notice, it's following the same shape as what you originally thought. So I actually don't need to graph my next one because I know the shape of it, but normally you want to do 3 or more points. So I'm going to do my last one, which is going to be f of 4. So I'm going to plug it in. And I'm going to get the square root of 4 plus 1. The square root of 4 is what? 2. 2 plus 1 is 3. So I know my last point is at 4, comma 3. Now I can keep listing points if I wanted to, but there's no point because once you have enough coordinates and then you know the shape of the graph, you're going to start at your starting point, keep it going, and that's your graph. That's how you do it. So every time that you have any graph, just make sure you always start off at the starting point, which sometimes can be found by setting the inside equal to 0. Okay? So hopefully that helped. Thank you for watching and best of luck.